We were trying to understand how many intersection points are there between a quadratic curve and a line. Okay, so it's not always true, it depends. Alright, so what we understood was that when I have a quadratic curve, okay, and a line itself, when we were doing Emaths, okay, we learned that I can solve for the solutions. So let's say this curve is y equals to 2x squared plus maybe 3x plus 1. Okay, and this one maybe y equals to x plus 4. Alright, so if let's say I have a curve and this straight line over here, okay, how many intersection points are there? And if I want to know the intersection points, I can solve it algebraically. Okay, if I want to know the x-intercept value, okay, I can solve it algebraically, and that is by doing substitution method, where I equate the two equations together. Okay, so that is what we learned also when we did our simultaneous equation chapter this year in our Emaths chapter 1.1. Right? And when I do this, it is as good as saying that I'm solving an equation like that, where I bring the x plus 2 to the left, which simplifies to simplifies to this quadratic equation over here. So having this quadratic equation, I can in fact draw another new curve. Okay. If I were to draw another new curve, I don't know how it looks like. For example, it would look maybe something like that. Okay, whereby my x-axis is actually over here. Right, and this intersection of this new curve, y equals to 2x squared plus 2x minus 1, okay, is actually the solutions to your x-intercept over here. So that's why looking for the discriminant of this new equation will be able to tell us, okay, how many intersection points are there. Okay, so that's why in our previous lesson, we very hurriedly actually ended off by saying that when the discriminant, okay, of the new equation is more than 0, it will imply to us that there is actually two intersection points. Okay, when it is less than 0, we have no intersection points. And when it is equals to 0, there is one intersection point. Okay, so it is actually parallel to our understanding of a quadratic equation, understanding how many roots are there. Yes, Richard.
Does this mean that y equals 2x squared plus 2x minus 1, like the x-intercept equals to the x-intercept of the line that passes?
Yes, okay, so the x-intercept with the x-axis, right, is the value of the these 2 points of x-coordinates. Yeah, they are equal. Yeah, because we did it algebraically and they are all equivalent steps. Okay. Right, so in our last lesson, we looked at exercise 2.2 question 3. Okay, today we will look at try 4. Okay? So a tangent is a line that passes through a curve at only one point. A line that passes through a curve at only one point. Okay? So how does it look like in a pictorial sense? We are looking at a curve. Oops, sorry, not very well drawn. Okay, a curve, and then the line that passes through the curve at only one point could possibly look something like that. So very, very, very. This is a height issue. Let me draw it. Okay. Okay, so it passes through at one point. Okay, so this green line over here is the tangent. Of course, there can be many, many tangents. I can also have another tangent over here. Okay, something like that. We are going to learn how to draw tangents into our graph in E-Maths chapter 5. Okay, so we'll practice that later. But that's how it looks like. Okay, so with the understanding that it only passes through at one point, that means that this line and this curve, when I equate it to get a new equation, my discriminant should be what? My discriminant should be equals to 0 because only passes through one point. Okay, so answer this. That's like that. Okay. But actually, we're not really quite solving it. We are going to find a discriminant. So the discriminant will be 4 squared minus 4 times 2 times negative k, which is equals to 16 plus 8k. And therefore we find that k is equals to negative. Okay. Or else I use what? Otherwise what you do? Because the question told us that the line is tangent to the curve. So that means that there is only one intersection. So there is only your discriminant must be equal to 0. Cannot solve this because this is that. Because got k but cannot solve. And then got x. One. So I have to use x. Okay. We move on to look at part C. sign of our discriminant. It must be less than 0. Okay, is it? It's less than 0, right? Because 0 intersection points. Okay, so could you please solve this and then determine the range of values of m? I'll give you about 3 minutes. It up. Alright, so we want to equate these two because we're trying to solve it algebraically in some sense or to derive a new quadratic equation. Okay, so it just so happened that both are y. Okay, that's why by our substitution method, I take equation 1, substitute in equation 2, this is what it will look like. Okay, it's not about just taking both right hand side that equal. You must see what is on the left hand side. So it's just nice that on the left hand side of both equations, they are both y. That's why we arrive at this. And then we get our quadratic form such that we can find out what is our discriminant, which is going to be 2 squared minus 4 times 3 times m, which is 4 minus 12m. Okay? The question says that does not intersect. Okay? Boys, I can hear you. Okay? Does not intersect. 4 minus 12m discriminant must be less than 0. So Yanni, our inequality over here should be less than 0 because of the does not intersect. Okay, not equals to 0. Then from here, then okay, we bring the 12m to the other side and we see that 4 divided by 12 okay, is less than m. In other words, m is more than 1/3. That's why, okay, not arrow sign but inequality sign, okay, is this way. So it starts from here. Okay, it's not a random decision. Okay, any questions? Alright. Now, let's look at another question. I will not go through try 5 because if we all take a look at it on textbook page 36, try 5 is very similar to what we were already doing in chapter 1.2. Okay, where we want to find the range of values of something when there's 2 real roots, okay, 1 real root or 0 real roots. Okay, so it is a regurgitation of what we did in chapter 1.2, so I will not do try 5. Okay. However, I'll go into try 6. Because they are both m on the left side, and then we move things around. Okay, I'm moving it to the right so that I can get coefficient y squared to be positive. That's just my personal habit. Okay, if you want to move everything to the left, that's fine as well. So it will likely simplify to this. However, we want to find discriminant. Okay, we need to identify the A, B, and C. A is a coefficient x squared, which you can see very easily. B is a coefficient of x, which maybe for some of you, you don't see it as clearly. So you may want to know that you should factorize out the x to get your 1 minus m. Okay, then you get plus 1. Then you can see very clearly for yourself that your A is 1, B is 1 minus m, C is 1. Okay. So the discriminant we get the question actually revealed to you the answer already by asking you to show. Right? So you need to provide more information over why is it that this is going to happen. So we need to provide some explanation. We say that since the line and the curve does not intersect or do not intersect, okay, which is actually from the question statement itself. Okay, so this provides the evidence for us to say that m squared minus 2m minus 3 will be less than 0. Okay, and then we have shown it.
In the quadratic form, okay, our A is 2, B is negative 2, C is P plus 2. Okay? Then we can find out what is the discriminant. That will be negative 2 squared minus 4, A and C. Let me just draw a divider. Which simplifies to give us 4 minus away 8, P plus 2, expanded into negative 8P minus 8 upon simplification. Did? Yes. Did I do a calculation error? Wait up. Or minus 12, sorry. Wait, but that's not all, right? Okay? Because the question says, show that the equation has no real roots. We want to show. That means that at the end of our answer, we want to say that this is going to be less than 0. We cannot claim that it is going to be less than 0 now. Okay? So there's a difference. I want us to be very clear about the difference. We want to provide the necessary evidence
to show that at the end this is going to be less than 0. Okay, so how am I going to do that? There is a piece of given information that we have not yet used, and that is this p more than negative 3 over 2. So because the question said that p is more than negative 3 over 2, we will use that to show that it causes this to become less than 0. So my objective is to have this statement. We need to fill out the in-between. Okay? So first of all, we will multiply by negative 8. So when manipulating inequalities, we say we multiply the nearest number to the unknown first. So multiplying by negative 8 will cause the inequality to flip such that we get negative 8p less than 12. Right? Okay? And then we can minus 12 on both sides such that we get our negative 8p minus 12 less than 0. Okay, so we arrive at this, which I can then erase already. Okay, so this is how we show that the equation has no real roots. So says the discriminant